Fiberglass or aluminum, what's the difference? Now, while each has its own appeal, few can argue that when it comes to ruggedness and ease of maintenance, an aluminum boat is pretty hard to beat. Now, although aluminum does offer some distinct advantages, when it comes to building really big boats, quite often the cost of fabrication drives the price beyond the range of many boaters. But now there's a company on the West Coast that's working hard to change all of that. Sailtech Yachts of Vancouver, Canada has developed a method of building an aluminum boat that is both faster and cheaper.
The properties of aluminum are such that it doesn't rust, it doesn't develop osmosis blistering, it doesn't rot like wood does, and pound for pound it's stronger than most other materials on the market. The reason that it hasn't been as popular as other materials is simply that the labor content in building aluminum boats has been so high that most people just couldn't afford them, and they were mostly reserved for people that had a deeper pocket than the average sailor has. Recently, within the last 3 to 4 years, we've come up with new construction methods that now allow us to compete in that marketplace ourselves. We've taken the labor content from 1,000 hours down to about 60 hours.
And then when I really wanted aluminum, and I priced the boat I liked, contacted the yard in New Zealand. He gave me a price in steel. So just as an example, what would it cost me to do it in aluminum? I just roughly see if it'll fit my budget. He said, well, about 40% more, which put it out of my range. Then when I saw this ad and talked to Gunther and the price was right, it was within my budget. I flew out, I liked the boat. Got a well-designed boat, so well-designed, a good designer behind the boat. I'm familiar with his work. And the deal was done in about 2 weeks.
Interest in this new method of boat building is growing, and Sailtech Yachts sets up a demonstration to prove to the boating world that they could fabricate a 40-foot aluminum hull and deck in just 3 days.
We set up this demonstration here to prove to the buying public, to the boating public, that this is a viable technology that even at this early stage shows a lot of promise. In conventional methods, we are forced to piecing the boat together in numerous small plates to achieve the intended design and the shape of the boat. In our new methods, we can literally use a full sheet of aluminum per half side of hull. And these sheets are computer designed, the boats are computer designed, and the sheet is pre-cut to a specific shape. This shape is draped over a mold, and we bring this shape together with various different cutouts that are on the plate. And it's obvious that a method that doesn't require numerous small plates and can be condensed into one large plate is going to be much, much faster to build. But not only that, it's also much fairer. The resulting shape is absolutely perfect.
Confident in their construction methods, Gunter and his crew of 5 set out to complete the task at hand of fabricating an aluminum boat.
The basic method is so simple that it requires very, very few sophisticated tools that allow us to pull, push, and prod the hull into its final shape. And the simplicity comes from the fact that we're using a single large sheet per side of hull. No joining has to take place. We simply fold it into shape. Once for each side of the boat, put the two plates together, the two formed plates together, seam it up the middle, and we have a boat.
We can only bend the sheet of aluminum one way. We can only bend it. We can't twist it. We can't stretch it. We don't do any of that. So without computers, that would be really very challenging, very time-consuming, and really very difficult. The computers are really what makes the breakthrough possible. It's much easier to turn a developable 3D shape into a flattened out section that can be plotted out on a flat sheet of material.
Gunter had been looking for a new method of constructing aluminum boats for a number of years, and he started out by making scale models.
We had worked out how to actually build the hulls. What we weren't able to do is to generate the proper numbers, in other words, the weights and balances of the boat off these small models. It's very, very difficult to scale a boat from a 1 foot size to a 40 foot size and stay accurate within that.
Gunter's search for a solution led him to approach Graham Shannon, the author of AutoShip, one of the foremost programs in use today in designing boats.
He showed me this method where you build the hull by starting with a flat plate and folding it up. And he had an example of a boat, of a model of that sort of thing, but it was fairly crude. And he said, "Do you think you could work out how to do this on the computer?" I scratched my head. I couldn't quite figure out how to do it at the beginning, but after a bit of work I figured out how to predict the way that the flat sheets would behave, and thereby design almost any boat that we wanted.
The solution worked right off the bat. He was able to generate the proper numbers for the boat so that we could predictably put a hull together and know what we had. The very first boat that he designed was a 44-footer, and the boat literally went together without a hitch. We constructed it to his drawings and to his computer technology, and were able to build that hull in a matter of 4 to 5 days. That was the very first one that we did. If this was to be compared to a conventional construction using frames and longitudinal stringers and then plating this structure with numerous small plates, it becomes obvious that this is a much easier way of building a hull. Anytime that small plates have to be formed into a structure, heat distortion takes place, welding marks are present, all this has to be ground out and faired out, and this is what we're trying to avoid. And we've been very successful with that.
Hulls created in this method are accurate to within 1/16 of an inch and largely clean and free of any welding marks.
The finished product looks beautiful. It is absolutely fair. There's not a wrinkle in it. There's no marks, blemishes, or weld marks on it, and requires a minimum of final finishing. In a conventional method, we probably use about 20 gallons of filler to make it into a fair structure, to make it aesthetically pleasing. In our construction methods, we're down to about a gallon of filler for simple cosmetic repairs on it.
Best described as sophisticated simplicity, Sailtech Yachts plans to apply their unique style of manufacturing to a variety of power boats.
The method of building these vessels in our construction methods is such that it lends itself to any kind of boat rather than just a sailboat. We happen to be sailboat specialists, and that was our first choice. We can build small power boats, we can build large power boats, we can build displacement boats. It really doesn't matter. The method and the technique always stays the same. And the savings generated will always be passed on because we can come up with a better looking product with less labor content.
With minutes remaining, the Sailtech Yachts crew push ahead to complete the demonstration, showing the advantages of this technique.
No one has been down this road before. There's no one in the world that can build boats the way that we do, as quickly and as accurately.
For the next step, Sailtech Yachts is planning to apply their technique from custom boats into full-scale factory production, making this one company to watch out for.